Well, thank you for the introduction, and this is tough because we've had two very fascinating papers, and this will maybe be a little bit more mundane. Is this what I press? Yes, okay. So let me just go back for a second. My co-authors here are Claudia Paul-Wostel, who I'm sure those of you who read the social sciences literature are familiar with, and Anik Badouri, who is a water economist and currently the executive director of the Global Water System Project Office. So first of all, I'd like to consider the emerging crisis in water security, energy security, and food security, because that's what's basically driving this particular initiative. The energy challenge, I think we're familiar with. In spite of the fact renewable energy is being introduced, people are being encouraged to reduce their consumption of energy. When you look at the growth in fossil fuel use, it pretty well is continuing as fast as it was going in the past, and 33% of this energy is being consumed in the production, processing, and distribution of food, according to the FAO. So that's where a third of it goes. And if you look at what the future projection is, this is looking towards 2030. While the developed countries, the OECD countries, are expected to use less energy per capita, there's going to be in the developing world a greater energy use per capita and a significant increase. And in fact, the overall increase that's projected here is 26%, if I'm reading that correctly. So as we think about food production is also under some threat, because by 2050, we'll have to feed at least 9 billion people, it's projected. And we'll have to do this with a changing climate, where there'll be less productivity in many of the countries which are at low and in some cases mid-latitudes. And we'll have to do it with changing dietary patterns, which if we continue on the current track will mean that there'll be a demand for higher intensity foods, if you like, such as beef and things of that nature, as the developing world develops an appetite for them. So if we look at the food production here, we find that food production and food demand, more accurately, is expected to increase significantly on a worldwide basis, some of that coming from the developed world, where there would be a small increase per capita, but a lot of it again coming from the developing world as they're able to purchase more food with better wealth. If we look at water, there are many drivers here for water. Perhaps the prime example of demands for water and the consequences of a lack of water are found in Africa. And Africa has a lot of transboundary river basins, so that water is influenced by the fact it's not managed in a consistent way from one part of the basin to another in those cases where it crosses basin boundaries. But in Africa, it's found that about 5% of the GDP is lost due to poor coverage of water services and sanitation, not to mention the number of people who die or get sick from diarrhea and waterborne diseases. 2% of the GDP is a loss due to the inadequate water available for power production, hydropower production. 5 to 25% is a loss due to drought. So there's a major setback that Africa has because they don't have secure water supply. And if we look at water overall, we saw that the increases expected by 2030 for food and energy were in the 25 to 30% range. When it comes to water, it's anticipated that there'll be a significant demand in the developed world as well as in the developing world for water, and so the net increase in the demand for water is expected to be 53% over the current usage of water. So we have a major problem on our hands, particularly with water, but also with energy and food. So this got some of us thinking that we maybe should be talking about the water, energy, food nexus, particularly since the Economic Council came out with its report in 2011 saying that water was likely to be one of the major threats to global security in the future because of the interplay between those three sectors and the potential for instability resulting from them. Now, this approach has been adopted to some extent by the Food and Agriculture Organization of the UN, which is starting to think about how it would manage food and water and energy in a little more effective way. And they're using this particular format of looking at the drivers of the change, population growth, diversifying and changing diets, cultural and societal beliefs and behaviors, technology and innovation, etc., and trying to figure out how those drivers are going to affect the individual sectors and how they can adapt through better data, using that data to produce scenarios for better planning, involving stakeholders more effectively, and engaging them in a process that could lead to some development and change. Now, there's a number of reasons why you might want to look at the water, energy, food nexus, because there are a number of benefits. First of all, a benefit to all of society, because we share a common environment, and if we could manage the water, energy, food nexus in a more integrated way, it would allow us to manage a very critical part of our environment and our economy. The nexus idea provides a basis for understanding the commonality between sectors, and it's a basis for bringing scientists together to discuss and bring data together to analyze how we might approach this management question in a way that would be effective. It also provides a basis for discussing trade-offs between the various sectors. And it's thought that we could see some pretty major gains. You think that 1/3 of the energy being used in the production and distribution of food. Well, if we could somehow produce ways of doing the same things with renewable energy, we could have some major advantages and major gains and benefit society in some pretty substantial ways. Again, technology could also help with making irrigation more efficient. So a lot of opportunities here. We need, though, to work on the development of more data sets, process models, tools, and solutions to address these problems. And the nexus concept, though, will allow for the beginning of a dialogue that should develop and allow us to move forward with some of the technologies in this area. So we see the idea of the nexus as being a platform for improving cooperation between the various sectors. Now, it's not easy, and part of that reason is because when you look at these sectors, they have developed over centuries by competition within the governments, by being there to produce what's needed by society. The food production community includes a lot of farmers, often operating at a small scale. A few of them who have amalgamated into corporations are able to produce a large amount of food and make money, but there's a lot of people around the world who do subsistence farming, and they're just producing enough for themselves and possibly their neighbors. When it comes to energy, though, we have a concentration of the power and the money in a few people who and companies who are able to generate a lot of money and have strong lobbies for their position. And when it comes to water, water doesn't have a dollar value attached to it. It tends to be fairly highly subsidized by governments, at least the infrastructure, and we don't pay the cost in any country that I'm aware of what it takes to get the water to the person who's using it in their home. So there are three quite distinct economic structures that we deal with when we talk about the water, energy, food nexus. There are overlaps, as mentioned, for energy. A third of the energy is used in the water energy in the food production. 70% of the water that's consumed is used for irrigation. And if you think of the overlap with energy, there's another probably 5%, depending on how you treat hydropower, that's used for that purpose as well. So clearly, if we're dealing with the water domain, a lot of it is in these three components. So there are significant areas of overlap that could be developed. There could be common management approaches and common information databases set up for water, energy, and food, where we could have some economies of scale and we could produce information that would allow people in these different sectors to work together and plan. And it's not only working together to use the information that might be developed, but also they could, within this framework, discuss things like climate change, because often there's incoherent approaches, even within a single national government, where one part of the government will say, well, we're trying to maximize the production of fossil fuels. Another part of the government will be saying we're trying to improve the ecosystems, and so they might be non-cooperative or not working in a harmonized way. A nexus approach might be able to overcome that. It'll also improve the economic approach to the problem, make stronger links to environmental services, and help to minimize the pressures arising from consumption that are occurring due to demographics. So we think that this is an area that's very fruitful. In terms of the Future Earth program, there is an activity that's being developed, the Sustainable Water Futures program, which is the Global Water System project as it moves forward into the future. The idea here is to incorporate some of the principles of the Future Earth program, such as making it more solutions-oriented. And so the problems are defined as being fully global, but we look at and focus on the regionally significant components of them and take certain topics that are opportunistic, and the water, energy, food nexus is part of that. The idea would be that within this water program, there would be 5 components: a synthesis research activity, which would be derived from what has been going on in the Global Water System project within the GEC activities, and there would be an outreach component, a capacity development component, and an implementation tracking component, where when there are interventions, policy-wise or with technology, those interventions would be tracked, and there would also be an assessment of the impact associated with them. To do this, it's conceived that there should be some sort of central virtual laboratory that would help in the process of co-design with partners, as we've been hearing. And part of the approach here is to begin with doing research through an innovation and assessment platform, and then work with global actor networks, and possibly some of the concepts that Amy was presenting would be able to help us with this. And then from that, move to a level where there would be discourse with society to try and implement ideas and hopefully move forward with some transformation. So now within this, we developed a plan to try to work on the water, energy, food cluster. This was started initially through discussions that we had at a workshop in March in Rome, Italy, where the Global Water System Project, the European Space Agency, and FAO got together, and we had a workshop, and from that workshop a number of recommendations came out. First, that we should have a working group to follow up, and that we should try to do some case studies or demonstrations and deal with a number of recommendations which covered things like relating the WEF nexus to the Sustainable Development Agenda, looking at how we can bring in governance approaches that would build on the power of information that's contained in Earth observations, how we could develop methodologies for supporting the water energy food nexus, such as reducing what FAO likes to call the yield gap, and how that changes over time. Then that was followed by a conference in May in 2014 where the GWSP and the United Nations Environmental Program held a workshop looking at sustainability in the water energy food nexus. And from that, there were a number of insights brought, such as issues like governance. It has to be ongoing development that's done in a polycentric governance framework where things are looked at not only at the local scale but at the national scale and with some global oversight. And there was a thought that we need to think clearly about focusing the nexus debate on solutions so that there'll be a strong push from the policy side to implement those solutions. Again, nexus problems were perceived as being multi-level and multi-scale, which argues for polycentric governance approaches. And the idea was to map similar classes of problems to classes of solutions in trying to identify how to solve particular problems. So about the same time as these discussions were going on, there was a call from Belmont Forum for some proposals. And a proposal was introduced. First of all, it was a proposal on the sustainability for water, energy, and food through integrated water information. And the idea that some of us on the physical sciences side had was that this would be an opportunity to showcase how Earth observations could be used to address the water, energy, food nexus more efficiently. Well, there was a criticism came back that we didn't have enough social sciences in it. But at the same time, some colleagues within the Global Water System Project had put in a proposal for governance. So they asked that these be merged together. And so governance is now part of the agenda here. And we've been working, trying to understand each other as we move forward. And it's clear that somewhere in between the governance and the observations lies the management component. And we need to develop those connections. So we have a couple of research questions that we're going to address. We plan to have 4 workshops, and we're hoping that those workshops can be structured so that we have some co-design and co-production of knowledge, and we do some networking. We expect to have sort of a research plan coming out of this, perhaps for a flagship, to support a flagship on the WEF nexus, and I understand there's been some discussion of this in Japan as well, so we have some harmonization with other activities that we weren't even aware of. But there's a lot going on in this domain at present. We were planning to have a statement of needs for data and information coming out of this analysis, and also some new tools and best practices for how information can be used in decision making. And we hope to produce a journal, a special issue, or possibly a book, etc. So moving forward, we're trying to frame the questions so we can bring together the ideas that are on the social sciences side and on the physical sciences side. And one way of doing this is to think about coming up with integrated information which brings together the physical data related to these 3 sectors, and also on the governance side, bringing together information, probably in a different format and so forth, but nevertheless bring that information together so we have a picture of how governance is taking place and how we interface with governance. And this would not be the domain of the physical sciences, it wouldn't be the domain of the social scientists, but we would bring that together. First of all, to identify outputs that are meaningful for the people who are actually making the decisions, and then we would work with them to develop knowledge that would enable them to come up with the outcomes that are necessary to have some solutions that are meaningful that they can implement. We have thought about the workshops. We're planning the first one in the Washington, D.C. area in May or June of 2015. We're working with the University of Texas, which has an NSF grant, and planning it out. It will have some priority themes, and perhaps this is more useful to show. One of the themes will be, because we'll be in the Washington area, is how Earth observations can be used. Interesting example here of how the GRACE satellite, which measures water storage and can be used to infer groundwater, shows how there's water depletion in different parts of the world. And in fact, in the area where the satellite is detecting large groundwater changes, there's a over-reliance on groundwater for the production of crops. Drought prediction will also be part of this discussion, as will the use of land. And we have to be very careful with how land is incorporated into this program, because it is probably in the long run just as critical as water in terms of the water, energy, food nexus. And so we want to make sure that we understand the role of land. The second workshop will be in Germany in July or August, we're anticipating. The Fraunhofer Institute is a partner with us on that, and some of the issues that we anticipate will be developed there deal with governance. This is just an example of a particular study that was done in Europe, but it kind of shows a profiling or characterization of governance approaches, where some countries use a hierarchy approach, others use a market system, others use a more networking and social system to come up with decisions. That whole process of decision-making has to be understood if we're going to interface with it. The water energy nexus will also be profiled in this discussion. Water is necessary for energy production, for thermal power, for hydroelectric production, but energy is also a critical player in the distribution of water and in the treatment of water. And of course, there are areas of the world where lakes have turned to wetlands and are not useful anymore. Africa is an area where there's some major opportunities as far as energy production is concerned. 21 gigawatts are installed. That's the installed capacity in Africa. They have a capacity with their rivers of having 285 gigawatts of energy. So they're using about 7% of the energy that could be used in Africa. So they're people that we really want to involve in those discussions. The next workshop will possibly be in Beijing or China or somewhere in Asia, but we have had some discussion with the Chinese Academy of Science, and they are interested. Some of the issues that will be dealt with there include the consequences of intensive agriculture. It has consequences for water bodies, as there is eutrophication in receiving water bodies due to the nitrates and phosphates, which are carried by the rivers into the lakes. And that's a common problem around the world. There are issues of land degradation as land that is not ideal for agriculture, but it's being put into service. And sometimes that's on steep hill slopes, so that the destruction of the natural vegetation has serious implications. Then there's the need to consider things like rock phosphate that's used in fertilizer production, and what the consequences are if that runs out for food prices. So a lot of issues there. And in addition, there are ideas about how we can extend ecosystem services by better management. And that will also be a major discussion in this workshop. The final workshop is planned for spring 2016, after the UN has finalized its decisions on the Sustainable Development Goals. And through that, we hope to particularly interact with a water sustainable development goal, an agriculture sustainable development goal, and an energy goal. Or if they're reducing the number of goals, they may combine or cluster those three areas. So we want to be clear on how Earth observations can be used to help with the monitoring of the goal indicators. And we also want to have some debate about how experience that's come out of past studies, such as this human water index that Charles Smarty has developed, how those can be used in sustainable development planning. Part of the problem that we see is that the data that is available now has tremendous spatial and temporal resolution, but the old way of doing the Millennium Development Goal monitoring relied on sort of a 2-year national-based assessment process. And we're wondering, how can we think more broadly about sustainable development so that we make use of that daily data that we're getting at 1 kilometer, 5 kilometer resolution, so that we can pick out hotspots of where sustainable development problems are occurring and fix them, rather than wait for 2 years to declare to the world we have a problem. So this just shows the time frame that we're moving along. The grant is for 2 years. We anticipate that most of what we hope to have done will be finished by August of 2016. And we're looking forward to the contributions that this cluster activity will make to Future Earth. We see it as providing a global platform for international scientific collaboration. It's a global platform. It's definitely not the global platform, but we want to test out ideas. We see it as being a pathway for enabling some integrated research on grand challenges and transformations to sustainability, particularly as they relate to water, energy, and food. We want this nexus to strengthen partnerships between researchers, funders, and the stakeholders. And so we will have stakeholders and practitioners engaging in these workshops to try and achieve that result. Finding solutions will be where we want to end up, and that could include things like closing the yield gap, reducing food waste, regulating groundwater use in some way, or at least getting a better handle on groundwater use, conserving soil moisture and capturing dew in very dry areas, so that will help with agricultural productivity. We've recognized that we face a number of challenges with transboundary river basins, with access to data on water, energy, and food, with coordinated action research to study and support learning and innovation processes, with co-design of sustainable development trajectories. We anticipate there's going to be a lot of debate and a lot of difference of opinion there. The development of indicators to support our assessments of where we're making progress. Comparative studies will be needed, and we don't have a good handle on where all the knowledge bases are that we have to access. But we do know enough that when it comes to UN conventions, that there's a lot of inconsistency between the data sets that are in those conventions. So being able to rationalize those is important. There's competition between the fossil fuel energy sector and the climate community that we'll have to address. There's non-implementation of a lot of trade rules that lead to subsidies. And we also have scale issues. Some of the implementation challenges that we face are to get the full engagement of the energy sector. We're not there yet. We're still working on it. Also, there's a challenge because when things are very young, they change quickly. When things are very old, they change quickly. And we're in a phase where we have a project office that's phasing out, and we think there's a project office phasing in, but the changes are happening just at the time when we really need the support here, and that's causing us a little bit of angst. So, at the end, let me say thanks go to the Belmont Forum for funding this work, to the Future Earth program for this opportunity, and to you for staying for the last session of this AGU meeting. And it's a sunset which you wouldn't be able to see outside anyways. Thank you. Okay.
I'd like to follow up on one of the last things you said about kind of trying to get better spatiotemporal resolution on things relating to like the MDGs about water access. I've got a student who's been working on that and finding that a lot of the physical data is available at high spatiotemporal resolution, but the social science and demographic data is not, and that's a very expensive, difficult thing together, but if you're trying to look at who actually has access to clean water on a seasonal level, you need to know, like, at the household level, how far is it to the nearest water source, what's the quality, and so forth. Any thoughts about the challenge of getting that kind of coverage on social science and demographic data?
Yeah, that's a challenge. The demographic data, Landsat does put out a very high-resolution scan product. It shows population density done on a yearly basis. So that's a source of fairly reliable data. Secondly, we have a lot of citizen science now. We haven't tapped that. The UN is talking about a data revolution, tapping into novel data sources such as citizens, science and citizen observations. But that has to be structured to be useful, but there's no constraint on setting something up so that we get some useful structured data that could have people taking observations of that pond that's next door to them or that lake that's a mile away, and they could provide the data that would be necessary to at least get a citizen's observation as to whether or not that's being realized. So yes, there's a challenge there, but I think there are opportunities and we have to mobilize to take advantage of them.
Thanks. I think we have to
Okay.
move on now.